Hello, friends, and welcome to another video of AI with Supreet. Today, we are going to learn the basics of adding memory to your program. And if you remember, in the last video, we created a chat application wherein we did not have an explicit memory available to the application, and the data that we were saving was not persisting. So, we had these two problems with the last application that we created. Today, we are going to solve one of these problems, which is adding memory to your chat application. And in a future video, we will see how we can make this memory persisting as well. Okay, so let's get started. I have created a console application already, and this time, apart from Microsoft Semantic Kernel, you will also need to install two more different NuGet packages called Microsoft Kernel Memory.core, and there is a stable version available for this. But you will also need to install something called Microsoft Semantic Kernel.plugins.memory, and for this one, there's no stable version available, so you'll have to include pre-release and then include whatever latest pre-release available. Okay, so with that in place, let's go ahead and start building our application. So we will first go ahead and add our using statements, which are Microsoft dot semantic kernel, and then Microsoft dot semantic kernel dot connectors dot openai. Because we are adding memory today, we need two more additional using statements, which are kernel memory and semantic kernel dot memory. We will use them today. Okay, so with the that in place, let's go ahead and copy paste our uh, configuration parameters. And although this screen is blurred, you'll see that I have got two more configuration parameters apart from our usual Azure development name, endpoint, and API key. I've got one more called Open API key and one more called Azure embedding endpoint. So what are these? Let me show you. So if I switch back to, let me first go back here, do there, and now if I switch back to my browser, you will see that if I open oai.azure.com, which is my Azure Studio portal, and there are different models available in here. I have created one more deployment model over here called uh, this one called text embedding ada 002. Now we are using this additional model to create the embeddings. Now let's take a brief and understand what embeddings are. So, whenever we want to add memory to our application, we are sort of adding some sort of, we are adding a way to store the data somewhere, right? And with chat application, it is not different. So, whatever chat that we are having with our application so far, we want to save it somewhere. The problem of saving this entire text that we are the entire chat history that we are having with our chat program, and if you want to save that as it is, it's a lot of data to be saved, right? So what embedding does basically is embedding breaks that data down into mathematical expressions which are short, which take a very small footprint when it is saved in the in the disk or wherever you want to save it. There are multiple ways where you can save it. So what embedding does basically is it compresses all of that data, it encodes all of that data, it creates mathematical expressions out of all of your historical data and saves that into a place. It takes far less memory if you don't use it, and if you want to save this entire context, the history, it will take a lot of memory, it will take a lot of database space, and embedding takes a lot less space. And what it does basically is it still has maintains that relationship between the tokens and the objects and the history and everything. It has that entire context available. It breaks them down into a mathematical expression and saves that mathematical expression, and then when you want to reuse it, it is able to reconstruct, and it is able to recall anything that you have given it into the memory. So that, and it's also very fast, right? So the search becomes fast, the finding of the specific data that is in the memory becomes really very fast. So that's where embedding comes into picture. So in layman terms, what embeddings are a way to save your data, to give your application a memory. And what it does basically is, rather than saving the data as it is, it saves them as mathematical expression in a way wherein it still has the entire context, and it remembers and knows the relationship between all the tokens that you have previously processed with your application. All right. With that in place, so we have created one deployment model called Tax Embedding ADA 002. Now, why this model specifically is because this model is considered to be one of the very good models when it comes to creating the embeddings, right? So we will use that. And then the second parameter that you should see today is that we have, if you will have to go to platform.openai.com. If you haven't already done that, please register yourself as an OpenAI developer, and I believe when you are following this program, you would have already done that. If not, it's okay. Please go ahead and register yourself as a developer on OpenAI. The URL is platform.openai.com. Go into API keys and generate an API key and use that key as well in our application. Okay. So with those things in place, now let's go ahead and start building our application. So what I'm going to do is I'm going to first create the same chat application that we had created earlier. So there's no change in there. So I'm going to just go ahead and do all the steps that we had done in the past as well to create our application. And there's no change here. It's still the same. It's still the same old application that we created, and I'll give you a walkthrough in a minute. Just give me a minute here. Okay. So you see what we are doing here is oops. So what we are doing here is we have created this builder object here, as usual. Then we have given it some Azure settings. We created the kernel object using the build method. And then we have our prompt here. In the prompt, we did not have this. So let me go ahead and let me go ahead and remove that part from our prompt. That is something that we will build later. We have two arguments called history and user input. Then we use this prompt to create a chat function out of it. And I don't need this as well right now. So no, nor do I need this. This is something that we will bring later. So we created these variables, created an argument called kernel argument, and then we created a chat application. And in the chat application, we read users input into this variable, passed that into the arguments, and then passed the kernel object and the arguments to the chat function to get the result. And then we appended the result with the AI's answer, and then we added everything back, appended everything back into the history variable, and added that into the arguments as well. So let's go ahead and run this very quickly. This should work, and this is so far up until now nothing different than what we had built previously. So hi, my name is Supreet. Um, Give me a few suggestions on productivity books. So I hope, yeah, nice to meet you. Give me a few suggestions. Okay, and then I ask what is my name, and it should remember me because we are giving it this entire history in this arguments, right? So now let's go ahead and add some memory to it. So to do that, what we are going to do is we are going to add this. Let's go ahead and create and build our first memory object. So what I will do is I will go ahead and copy this step number 5. So just below the prompt, I am creating this memory. Now you have to see what we are doing here. So memory builder equal to new memory builder. This is under semantic kernel dot. Sorry, this is under our pre-release NuGet package that we had installed earlier. Now it will throw some warnings, like here it is showing. So you will have to suppress these warnings by providing this pragma, or you can do that by fixing it in Visual Studio. You'll have to suppress them, uh, suppress these configuration issues in the source. You'll have to do that. Why we have to do that is because these, as I said, are this is available under pre-release of NuGet, and it is supposed to change. So it might get deleted, it might get changed in the later versions of semantic kernel. So we will have to suppress those warnings by using this pragma warning disable notation on top of memory builder with so I'm creating a memory builder here, and I'm using the OpenAI text embedding generation. I'm giving it the model name, the deployment name, the endpoint, and the API key, right? Then I am saying that memory builder, and I want to use a store. Where do I store the memory? So I want to for this particular case, we are using volatile memory store. Now, what does this mean is that we are still not saving the memory in disk or any database or any permanent persisting place. This is still in the session. It's still a volatile memory, and that is okay, because if you want to just save it elsewhere in a persisting way, all you have to do is to change this from volatile memory store to any other memory store, such as simple file storage or simple, um, I can do maybe simple vector db. Yeah, you can do that, right? So we'll talk about that later, but for today we are not saving it persistent in a persistent way, and we are using volatile memory store to create the memory. Now, once the memory is created, let's go ahead and build our arguments a little. So what we are doing here is that I am introducing a new memory collection over here, and I am going to add the history parameter into the arguments, and there is a new argument that I have introduced, as you will see, is called fact, and I will say my name is Preet. I am from India. I love learning new tech. So I am giving it some facts, and then we want to store these facts in the memory. So what I'm going to do is I'm going to copy the so what we are also doing here is, if you see that we are adding these in the arguments, we are adding these collection param equal to memory collection param, that is nothing but a string name. Then some other configurations, limit param and relevance param. What this does is basically it allows us to search in this memory. In this memory, we are adding a small raw text as facts, and then we are giving it some configuration so that whenever it is searching into the memory, with what values or parameters should it search, is something that we are defining here by the limit param and the relevance param. How, what should be the relevancy of the items that we are searching for. But instead of the text, you can actually feed it with another URL or a document or any other kind of source of data, and build even complex application. And we will do that in our one of our future videos. So again, I'll have to suppress the configuration issues here. So I'll do that, and I'll do that for all of them. In fact, I'll have to do that for this step as well. So let me just bring everything in here. So what are we doing here is that we created this memory builder here, and memory builder with volatile memory. Then we gave it a history. And where is this fact argument coming from? I'll have to touch base on that a little later. Just give me a minute. But then we also gave it some parameters, execution parameters. So whenever it is searching in that memory here, in this old text here, what are the configuration through which it should perform that search is happening here. Sorry, is happening here. Then what we are doing is we are just adding this memory plugin. So I forgot creating this memory builder here, doing that, and then I forgot creating a memory out of it. So we will use this memory builder configuration, and we'll use the build method to create the memory object here, and then we will use that memory object to uh, pass in the kernel. So now kernel has a plugin with our memory object, so the kernel is aware of our memory now. Okay, with that in place, I think we are ready. The only other thing that I need to change is my prompt. So in the prompt, what we will do is, in the prompt we will add our memory like this. So if you see that we are saying that I am adding it some memory, wherein we are saying that there are some old memory objects, and I'm calling it fact. That is the fact about me, that I'm supplying it before the build um, predefined, right? And then the recall method, which is available in our memory object, allows us to recall that memory, search for that memory during the chat that we are doing, right? So up until now, if you remember that whenever we run the application, I used to give it my name and then ask for it, right? So now I have given it my name in a predefined way. So it is available in the memory. So let's go ahead and run and see if we run into any issues. So it says that dependency memory dependency. Okay, so I just created this memory builder dot build memory below this line where we had asked it to update like what memory store to use. I was earlier using it here, and that's why it was throwing errors. So I just cut and pasted it below this line. So what I had to change here is, if you remember, I gave it this entire text. Instead of that, I am giving it a very simple text right now, saying that my name is Supreet. And then let's run this again. So we are giving this a fact here, and run this application again and see this. And it's starting up. The chat application has started up, and it has started up with a pre-built memory. So let's see that whether it knows about us. So hi, what is my name? Sure enough, it knows that. Thanks. Um, Update my name to S3. Thanks. Now, what is my name again? See. Thanks. So you see now it's able to save that memory, update that memory as well, and it is able to start with a given memory. And as I said, instead of this small text, you can actually go ahead and preload your memory with your entire web pages or documents or PDF files and whatnot. And this is something that we will look into the future videos as well. Apart from this, what we will also look into is that how to save this instead of using volatile memory, how to save this in a permanent persistent store. Again, something we will look into future videos. So I hope this is useful. I wanted to leave this video with one more note, that memory builder, as I said, is available in the pre-release of the NuGet packages, so it may change. There is a substitute available as well, and it is called kernel memory. And from what it looks like, semantic kernel team is focusing a lot more on kernel memory than semantic memory that we are using here. um, but I don't know for sure. Although the kernel memory is a lot more advanced, and it is capable of doing a lot more operations than semantic memory is able to do today. And that is available in the stable version of NuGets as well, rather than in the pre-release version. So that is something that will be, if you use that, it is going to be stable, it's not going to change. So in one of our next videos, instead of using semantic memory, I think it's a better idea to go ahead and start exploring kernel memory, right? So we will give it some documents, some web pages, and we will do chat on that RAG application, the RAG applications. With that, thank you so much. I hope this video was useful. um, Sign up, subscribe, share. Thank you so much.